Hello, my name is Rick France, and I am a solutions engineer here at Hagerman. And today we are going to be talking about interactive single line diagrams using AutoCAD Electrical. You should be able to see my screen now. And to start with, I'm going to just show you a little bit about this one ladder diagram of a three-phase that I have here, because this is the one we're going to use to interact with. I'm going to zoom in here on one of the motors up here for the air fan. This is the primary air fan motor. There's also a secondary air fan motor and a tertiary air fan motor. And it's basically the three-phase one. It's completed here. If you looked at any of these components, they've already got all the manufacturer information, catalog information in it. And it's basically ready to go. So we're going to be basically in our single line diagram that we're going to create, we're going to use the Circuit Builder in order to build the motor here in the single line, and then we're going to use regular icon menu to build the power supply over here on the single line and then connect them up. The reason we're doing them in two different methods is basically to be able to show how you connect them up when you're using the Circuit Builder, and then how to connect them up when you're using them in the icon menu, because there's a couple of minor differences, but we wanted to be able to show that so you could see it for both methods. Also, in addition, you'll notice here that I am using a fuse switch for the three-phase on the motor. I chose to do that instead of a fuse simply in order to show how to what was necessary in creating a custom symbol for a single line, one-line component, because they are different than just a normal schematic symbol, but very minor how they're different, but I needed to show that. And there's not a fuse switch out of the box here, so that's the reason I chose to use a custom component here for that. So I'm going to go ahead and create my single line document, and I'm going to create the new drawing just like I would any other one. Now I chose to create the drawing from scratch, mainly in order to show how the difference between my one-line template and my regular schematic template. Basically, let me go ahead and get this filled out here. So basically, you can see up there at the top, let me get this last little bit in here. You can see up here that I'm using a one-line template that I've created that has my title block and everything on it. When you browse, you can see I use quite a few different templates. My ladder template, which is the one I used for this three-phase, and my single-phase ladders and my one-line template are different, but there's only a couple of parts of it that are different, and I'll show that in just a second. First, we'll go ahead and create this drawing. Now, here's one of the reasons I use two templates. The ladder for my three-phase, you can see, is a vertical ladder. If you looked at my single-phase, which I'll point out that one here next, it's also a vertical ladder, but when I'm doing my single line diagram, I want to use a horizontal ladder. So because of that, I've already got that defined in my template, so I am not going to apply the project defaults, which I will point that out here in just a second. So not applying the project defaults on it, it creates the drawing with that particular template. I'll go ahead and open up my single phase here. As you can see, it's a vertical ladder. If I look at the drawing properties for it, it's using a vertical ladder with 1-inch spacing. Everything else, the cross-referencing, the components, all of this is already set from the project this way. This particular template that I'm using has all the exact same settings as the rest of the project. All the same cross-reference components, that type. Wire numbers don't really matter because there's not going to be wire numbers on a single line. But the drawing format, this is the main difference, is horizontal. I'm using a 2-inch spacing. if I applied the project defaults, it would have overwrote those two items. Those are the only two items that would have been overwritten, and I'd have to come back in here and reset them. So I have it set up to where my template already has the type of ladder I want. Now, the reason I have it set with 2-inch spacing is strictly because we're going to be focusing on making the single line diagram interactive with the rest of the project. Let's say I'm creating a single line diagram that's a standalone, that's not going to be included in the rest of the project. In that event, I would want to add a ladder just like normal, but I'm just going to add one in here real quick. And I would do it with no rungs, but set up my ladder, insert this one, insert at 220, and then I would trim this wire out. And by doing that, I would get my numbers across the top for my rungs, and that way when I started inserting this, it would number everything properly, keeping them unique. So if I was doing a standalone single line, I would want those rung numbers so that it would be able to number all my components based on that. Now I could also start with it this way and just erase those rung numbers when I'm finished after I've hooked it up and made it interactive with the other drawings. I don't want to do that because since I am planning on using it as an interactive drawing, I'm going to go ahead and use it by just drawing a wire. Now, by doing this before I draw the wire, I'm going to use my grid, which I also have set up in the template. And basically, it's set up along with the snap to do a 1-inch grid with 2-inch major lines. Makes it a little bit easier for me to make sure everything's nice and even across this when I draw it. And I'll draw it by adding a wire here in just a second. But first I want to show you the only other difference between my ladder template and my one-line template are the wire layers. If you looked at one of these ladders, I come up here and checked out the create edit wire type, you can see I have all my wire layers that I'm using in this drawing. They're all getting wire numbering. When you're using a single line, there is only one wire layer, and it's called 1 dash. This is hard-coded in the program. It's not something I can change, but it's a layer name called 1 dash, and it's wire numbering no, because there's no wire numbers on this one. And I also made this my default. Now, if I was to start a drawing and it did not have this wire layer in it, the program would automatically add that wire layer, that wire to the drawing, and it would be set up exactly like this. I have it in my template simply so I can control the color of it because it would be white out of the box. But putting it in my template already and having this set up, I can control and make it a red wire as I did in this case. So that's the only difference between the template. It's an exact duplicate of my ladder template with those 3 changes made to it. The grid one is not required. That's just a preference of myself. So I'm going to draw a wire up here, and I'm going to start it at this point on the grid. Again, I got my snap on so that I could snap right to it, draw that wire in there. And since it was a wire layer, my default layer is 1 dash. That's what it placed in here, was 1 dash. So this is just getting it started in my template. Now, in addition to this, back here, before we even get started with the circuit builder, I want to point out the symbol that I'm using here again. Back here, I'm going to be using a fuse switch. So I'm going to go ahead and turn that off. Close that drawing. And I'm going to go ahead and open the fuse switch. I've already got it created. It creates using the symbol builder exactly like any other schematic symbol. So there's not anything unique in that sense about creating it. But there is one major difference that it has to be picked up. So I'm going to browse, come over here to my library and open up that symbol so you can see the difference. The most important part here is making sure you have the right library path. when you hit the little down arrow here, you can see there's different library paths for different types of symbols. And you'll see the second one here is 1-, and that's the library path for the templates for the single line components. So I'm going to change it to the 1-. You have, just like with any other symbol, picking whether it's a horizontal parent, all the naming convention still applies as far as the way that you name your symbols. They still has to be V or H for vertical or horizontal, your family code, and then 1 for parent, 2 for child, 1 for normally open, 2 for normally closed. So all that still applies, but I'm going to be doing a vertical parent. I have different types here, a few less that are here for the single lines, but the templates, this is going to be a fuse, so I'm going to pick it. So we'll open this up, and as you will see here, let's close that tool palette there. As you can see here, all the required attributes are already in the drawing. Again, this was an existing symbol that I've built customized, so I put in all the required attributes. I've got in my wire connections for where it's going to be connecting up to the wire. Everything here was done exactly like a normal schematic. The only difference is, one thing I had to do custom is I added this contact attribute that was not there originally, and it's basically the one that defines whether it's normally open or normally closed. So I've got the contact one in there for the normally open, so that attribute was in there. It's the same attribute that would be in a normally closed, normally open, normally closed symbol that you created that was a regular component. But the main difference here is this one called WD type, which is right here. This is the attribute that does the magic. You can see it's one of the required ones that needs to be in here. So it came over from the template. Since I used that template, it was okay, but I could literally take a normal schematic symbol, add that attribute, set the value to 1- or 1-, and it would be a single line component as far as the software is concerned. But that WD type is what tells the software this is a 1-line, single line component. You'll also notice that it's symbol I've got drawn here with a property width, global width. It's a polyline of 0.01. It doesn't have to have that. Like I said, I could take a normal symbol, add that WD type, set it to 1-, and it would work just fine. But those symbols out of the box, if you open one up, they're all set with this, drawn as polylines with a 0.01 width. So I wanted my symbol to look just like the ones out of the box. So that's why I created it with the same method of using that width. Outside of that, this is no different than any other schematic symbol. So I'm going to go ahead and close it. And I'm not going to save it since it's already created. We'll close the drawing out. And we're ready to add this via the circuit builder, almost. There is a minor change that I'm going to go ahead and go over first, and that's why the circuit builder was listed in one of the things we'd be covering here. We're not going to go into a lot of detail on it, but this is basically the out-of-the-box circuit builder with a minor change. I guess it's fairly major, I don't know. But anyways, when you open up this Excel file, which is basically the database that works the circuit builder, you can see it's divided up by 3-phase vertical, 3-phase horizontal. Here's my 1 single-phase vertical, my single-phase horizontal, and of course 1-line horizontals and 1-line vertical. I'm doing a vertical ladder or vertical rungs. Horizontal ladder, vertical rungs. So my symbols will be vertical, so that's why I'm looking at the 1-line V here for vertical. Now this particular file, there's not a lot out there that I've ever found defining how this file works, so it's pretty much I threw a dart just to try it out, see if I could figure it out. I knew when I had ran this previously in the circuit builder that I wanted this to be part of the safety disconnect at the load. So I found that section on this particular page of this Excel file. I basically inserted a new row, and I literally made an exact copy of that row there and just pasted it right down here for the next row, and then started looking for what I needed to change. Obviously, this was not going to be disconnect switch. This was a fuse switch, so I had to change that one to fuse switch. This column here, again, there was nothing I found that really explained it. So what I did was basically look at the one up here, and I saw that they were doing it as 1, 2, 4, 0. This one originally was 2 and 0, so I just made this one 4 and 4, just like the one above it. I just matched it. Now what this column is, if you came up to the top, you can see this is a UI value and a UI selection. They're basically ID numbers for the selection box, and ID numbers for when you're selecting this, you selecting item 4 and setting it to 4 so that it knows which one to use out of this file. So they're basically for the selection portion of this. So in each section they have to be unique. So that's why I went here, and you can see there's kind of some of these, they work together. If you look down here at the motor, for instance, it's selection 1, and then you have different options here. Again, I just kind of followed what I saw them doing up here. So as soon as I saw that up here that they were doing 2 and 4, that's how I chose to set those as 4. It was just a dart I threw the very first time I came in this file. It happened to work, so I just assumed I did it correctly. But again, I have yet to find anything who really goes into the detail to explain all this. Right here, it was an exact copy, and it was obvious that right here that was the name of the block, so that's what I did. I took the name of my block, which is VFU11_1-SW, same name as my drawing file back here in my library, and I just replaced the one that was there with that block information, left everything else exactly the same. This line didn't change at all, and the last two here, family code and a description. So basically I actually changed 1, 2, 4, 3, 4, 5 columns, 6 counting this one here. So went through and just changed the information there. That's how I got my new piece to work in here. So I just took one that was already working out of the box and made a couple of minor changes to it. And that added my fuse switch to the circuit builder. Like I said, we're not going into any more detail on that because that's not the purpose of what we're doing here, but I just wanted to show you that I did that in order to get that custom component into the circuit builder. Circuit builder is right here. I'm going to open that up. And as you can see, it's divided up basically into all those each tab. So these are those different tabs that are in that Excel file. So I'm going to be doing a one-line motor circuit. I'll open that one up. This one's going to be a vertical FVNR non-reversing. That was the one I chose in there to set that up with. And once I've selected that, it's a matter of just selecting configure right here. And we'll place it right up here on our wire. And that opens up the circuit configuration. I want to be able to use this over and over again. So I'm going to call this one my air fan motor. And that way we'll save this into my database, and I'll be able to use this same exact one multiple times without having to go through the configuration every time. Now, first I want to step back again and just talk about if this was a standalone single line diagram, then I could go through here and fill out all this information. That includes going to the motor symbol here and manufacturing catalog information, and it would be saving this information to the air fan motor so that I would get the exact same load, voltage, whatever I need to get out of this particular this circuit would all be set to this one that was saved over and over again. That's great if I'm working on this as a standalone. I want this to interact with the rest of my project though. So I'm going to be linking this up with that single line schematic or the three-phase schematic on the first drawing, I want this to understand that this is the same motor, the same circuit, the same everything that's on that three-phase is the same one that's on my single phase, the same motor starter, for instance, and the same one on my panel drawing. So because that's already completed on those drawings, I don't want to duplicate work. So I'm not going to fill out any of this information. I only want to have to do work. I don't believe in duplicate work. So I only want to do this once. So I'm basically just going to configure this and then connect it up. That's what our goal is here. So we'll start here with the motor symbol. Yes, it's a three-phase motor. So we'll keep that. My disconnecting means that particular circuit breaker was a circuit breaker magnetic instantaneous. You can see I've got different kinds I can use here, but that particular one was a circuit breaker magnetic instantaneous, so I'm going to pick that one. Motor starter, yes, there was one. Go to the power factor connection. No, I did not have that on my three-phase. Overloads, I had a thermal, so I'm going to leave that one as thermal. My terminal strip connector, I did not have a terminal strip or a connector on the three-phase, so I'm going to tell it none there. Cable marker, I did have a cable marker on that three-phase, so I'm going to go ahead and say yes, so that I can have this sync up with the cable marker as well. And then my safety disconnect at the load, this is where I added that fuse switch to the Excel file. So this is where it's putting that custom fuse switch that I created from the circuit builder. Once I've got all this selected, it's as simple as coming down here, the third one from the left. This is insert all elements into my drawing, or inserts all the circuit elements, so we'll pick that one. It inserted all the blocks from that Excel file that were defined into this particular circuit, and at this point I am done. And so there's my single line coming over from the circuit builder. Now I'm going to go ahead and put in this is the primary. I've got a secondary, tertiary, so I'm going to go ahead and come back into the circuit builder, but this time I'm going to come from history here and pick the air fan motor. Now if you don't see that, it's because the history has been collapsed, so you may have to open that up in order to find that. I keep mine open all the time because I create a library of these that I can use on job after job. I pick the air fan motor from my history, hit insert. We'll go ahead and place the secondary one in here, and then I'm going to come back here and put the tertiary one right there. So there's all three of those added in, ready to connect, and you'll notice they each have their tags in there already, but these are the tags they are getting from this drawing. I've got the question mark in there because I don't have rung numbers. I drew this as a wire, not a ladder. If I would have left the previous ladder in there, it would have put the rung numbers in there, and I would have had it that way. But these are going to be taking on the numbers from the three-phase because I want this to be the exact same circuit, magnetic instantaneous, that is on the three-phase. So to do that, to connect this up is rather simple. You just basically go to Edit Component, and right here there's a button called Schematic, and that's where the magic is done. Now the first time you come into this, every drawing session, these will revert back to unchecked. And this is the information I want to pull from the other drawing, so I'm going to select all of the above. Now, once it's selected, as long as I'm in this drawing session, in other words, as long as I don't close AutoCAD Electrical, that will be remembered from this point on. But the second I close AutoCAD Electrical, reopen it, those will be unchecked. So I have to make sure to check that the very first time, every time. Right, here's my primary air fan motor disconnect. That's the circuit I'm connecting to on sheet 1. And then I'm going to say copy tag. It wants to know if I want to overwrite this bogus tag with the circuit breaker 105A, and then I do, so I'm going to say OK. It overwrites the tag and pulls in the description, the manufacturer catalog, pulled in the item number. pulled in all my installation codes, my location codes, and even my rating. So it pulled all that from the 3-phase. I'm connected up here. Basically, I can just hit OK, and there's the information. Now I'm going to go ahead and do these while I continue to talk. I know you don't want to sit here and just watch me do each one of these. It's a little bit of effort that's to go in here, and the fact that you have to do each one individually because you got to connect it up with the other drawings. And so there's no magic button to just say this is that circuit, make everything the same thing. You do have to go through here. But as you can see, as I'm doing this, and I'm just taking all the defaults. As you can see, it doesn't take a lot of time. It's just making sure you select each of the right components that you're connecting up to. It's just a little bit of extra work that is well worth it, because I guarantee you I can connect these up faster like this than I could have added all that catalog information, the descriptions, everything that would have been involved in creating this as a standalone would have been a lot more time consuming than what it's taken me to go through here and just pick these, hit schematic, select the correct one, copy tag, okay, and move on. Now I'm going to skip the cable marker for now. Cable markers and the motors are a little bit different. Not a lot, but they are different. So I'm going to do those last here after I finish up the fuse switch. You can see my custom fuse switch is connecting up just like anything else. So there's my last fuse switch. We've got that connected. All these are now one and the same device as the one on the 3-phase, on my panel, on my single phase, everything, wherever these are in the project, they are one and the same. We'll show you that here in a little bit later. Cable markers are just a little bit different. And it's kind of silly, but here you go. You can see there's no schematic button. What you use on a cable marker is the one that says tags used so far. So I select tags used so far, same exact dialog box. I'm going to pick my primary air fan motor cable, copy tag. As you can see, it's working exactly like the other one. The only difference is instead of a schematic button, it says copy tags so far, or tags used so far. So it's very, very minor difference. I cannot explain why they used a different name for the button. My best guess is it was 2 different programmers. All right, the motor also has a minor difference. We'll see this in the power supply that we add later from the icon menu. But the motors has a minor difference in the sense of one extra question. It's still a schematic button here. But when I connect up to this motor, I get this extra dialog box right here. The reason you get this extra dialog box is in the motor symbol, there's an attribute called WD tag alt. And that is for setting up peer-to-peer connections for coil pins and that type stuff. I wrote an article. You can go on Hagerman.com under the blogs, and one of my most recent articles, actually it's 2 articles, but the second one part of that article gets into peer-to-peer connections, and that's what this is dealing with. This one is not going to be peer-to-peer. It's the exact same component, so I'm going to use option 1 here, which is tag 1. After that, it's the same thing. So it's just that one extra dialog box on the motor because of the peer-to-peer connection possibility that you could use if you needed to do that. But in our case, we don't. So this one is now completely connected up. It's an exact duplicate of the in a single line diagram form of that 3-phase motor that was on sheet 1, and everything's hooked up the same way. Now we'll come back here and show all the internet, how it's connected and how that all works here in a minute. In the meantime, before we do that, we want to go ahead and set up. You can see there where it's got those same numbers and everything. We want to set up this power supply, and I'll go ahead and throw a transformer in there just for the fun of it, because the power supply right on this one is a redacted version of a project so that we can keep it simple for this particular video. I'll do the transformer and 2 circuit breakers and a power supply that we're going to connect up drawing manually from the icon menu. So when I'm drawing from the icon menu, of course, you're going to need a wire. So we're going to go ahead and draw our wire in here. And I'm just going to stop it. Again, I'm using the grid to kind of eyeball where I want to stop this at and get everything to where they're about the same length. And there's my 2 circuits I need for the 2 power supplies. So we'll start out here on the icon menu. One-line components in the icon menu are all under one-line components. I do not want to use a push button or a circuit breaker or anything like that from the regular schematics. It will not see it as the same device. When I do that, it'll see it as a duplicate tag. And I want the software to understand that this is the exact same circuit breaker. It's the exact same transformer as on the other drawings. So to do that, I'm going to use the one-line components because these have that WD type attribute in it set to 1-. And that's what keeps it to where it understands they're the same component, not duplicate components in the database. I'll go ahead and put the transformer in first. I'm just going to stick one up here. All right, so now we're ready for, what I didn't do was connect it up. So I'm going to go ahead and go back up to Edit Component, Schematic. There's my transformer. Same thing, copy tag. So it's still connecting these up the exact same way. The only difference is I'm doing it while I work here. So we'll go ahead and get a circuit breaker on here, motor control, because this time I can connect them up as I draw them. And I am going to make sure to do that this time because when you do it this way, this is where there's a minor difference. I'm going to pick my power supply, hit copy tag, OK, pulls over the information. This time I'm going to hit OK repeat so I can put the second one in here. I have to task it. If I'm doing it with Edit Component, there's no need to task it. It works without it. But when I'm doing it as I'm inserting it, you have a task that you need to do. So I'm going to go ahead and put in the second one, and you can see it's got all the information from the last one, just like it would in a regular schematic. But we'll go ahead and put this one in, task it, and then we're ready for the power supply. I chose the power supply and wanted to add that one in here because you can look through all the one-line components. There's not a power supply in here. So most people just use what's called a generic load box. Those are found under miscellaneous. And here's the generic load box. That's what I'm going to use for my power supply. And we'll place it right there. And now we'll go connect it up. Now here's one of the differences because I'm using that generic load box. The family code for it is a DV for device. My power supply family code is PS. I only see here by family code because that's all I have checked right now. So it's filtering out by the family code since it can't find it. There's nothing to connect to here. So whenever you're using something that's such as that has a different, more generic family code, you need to add show all components for all families. Now I can see every component that's in here. In this particular case, I want the power supply. So I'll come down here. There's my power supply right there. We'll copy the tag. Same thing as the motor. It's got a peer-to-peer coil pins alternate tag there. So we're going to use tag 1 on it just like the others. We'll go ahead and say OK repeat, task it, and place this last one right like that and connect it up. Don't have to check the box again. It's already checked. And as you can see, as I'm placing these things and connecting them up here, it's removing them from the list because it's seeing that I've done it once already. It's not going to make me search through the list over and over again. So there's the one I put in manually. Since I did task all that, I'm going to go ahead and run those tasks. I don't like to leave task sitting there to where something might get duplicated. And as you can see, it's going to go to each of the other drawings wherever there's a power supply or a circuit or anything that was just connected up and making all the changes from the task. So that's the main difference in placing these separately. Is that Very, very minor differences between them, but there is a little bit. To show you how this is all hooked up, we're going to go do some surfing here. But I think first, before I do that, I'm going to go ahead and put a location box in here. And for doing that, I'm going to go ahead and unfreeze a layer. This layer, the layer for installation location codes, was also frozen in my template. And as you can see, I've got some of these that are on sub C. They're all on OS1, but sub C, and then I've got some over here that Transformer doesn't even have installation location code on the other drawing. And I've got one that's sub R and one sub C, so they're kind of a mixture going here. And then down here, you got some that are on the floor of the field and at the motor, things like that. I know that I'm going to be putting all of this inside my panel on subpanel R, subpanel right. So I'm going to use a location box. Now, if I went over here to my single phase, and I turned on those codes, you can see same thing, sub C, things like that. Come over here, that one's sub R, that one's sub C. So it's got all those same location codes because they're the same device. So I'm going to use a location box here and just come right above like that. We'll go through about that area right there. Place the location box. This one's going to be an installation of sub right, anything that's inside that box. And the location, of course, is still OS1. Now, since I'm putting a location box in here, I want to put some text over here that just defines, because I don't like to leave, I won't be leaving my installation location code turned on. This box represents that. So for the box description, I'm going to use the installation location values right there. I like to do it with a slash myself instead of a dash. So I'm just going to change it to a space/space instead of a dash. I think it reads a little bit easier. I can change my text height, set my description insertion point. I'm going to do it on the left so it comes out here on the left of the box. Once I have that set, hit OK. Yeah, go ahead, scan and update. And because everything is connected, it's going to go to the other drawings that are involved and make that exact same change. So now they're all the same. Everything's turned off to where I don't see what I don't need to. But everything here is now, if I had it all, I had the attributes hide selected that time, so it hid the attributes. But for that, but you could look here and see that it is all set to sub-right OS1. It made the change to every single one of these components with that location box. Now, if I came over here, look at this circuit breaker, did a surf on it. There's everywhere in my project where that particular circuit breaker is. You can see here, there's 3 of them right now on my 3-phase sheet 1, and plus the one that's the one that's in my single line. I can tell it one's on sheet 6, but also by the category over here. We'll go ahead and surf and take a look at this one here. And it'll go right to it, zoom in on it, so it's just working just like it would any other piece in here. So let's take the motor starter here. Let's do that one. There's a lot more on it. I'm going to surf on that one. So here you can see for that one, there's the one I'm on that I opened the surf on. There's the parent on my single line for the motor starter. These are the 3 right here on this drawing. That's my auxiliary contact, also on sheet 2 on my single phase. That's the one that's my single line right there, and there it is on my panel. So I'm able to surf just like anything else. Go straight to that parent there, let it open up, zoom in on it. So there's that same motor starter. Here it is on my panel. Same motor starter on this panel. We'll zoom out a little bit. So there it is on the panel. Take it right back to my single phase. And there's that same motor starter on my single phase. So everything's hooked up. It's interacting with the rest of the project exactly the same as any other device. I could come in here and tell it, this is primary air fan. I'm going to do the circuit breaker here and say this circuit primary air fan right here is going to be primary air fan number 1. And I'm making this change on my single phase. Hit OK, hit OK. It's going to go right over here I'll just open it up this time because I know where it is. And there you see that same change on my 3-phase. I'm going to come over here to my sheet 2 here. We'll zoom in on this motor starter where we were earlier. Change this one to primary air fan number 1. And it's going to make that same change on every other drawing. Went to right there. You saw it go to a couple of different ones. And if I come over here now and look at my 3-phase right here, motor air fan number 1, come over here and look at my single line diagram, primary air fan number 1. So everything's interconnected. If I change a catalog item, it would change the manufacturing catalog. It would change that on every other drawing, just like normal. It would change the footprint if necessary on the panel drawing. If I change the item number on the panel, it's going to come make sure the single line and the 3-phase and the single phase all have the same item number. So everything is working together. It's truly working interactive with the other drawings. I can also, by the way, use source and destination arrows to take this from one single line to another, take it to another drawing. There's nothing different on the source and destination arrows for this one line drawing, the single line drawing, than there is for a regular schematic. It's going to work. They work exactly the same. They just have to have a unique code. And that's pretty much all that happens here. Now, this is a re-recording due to some technical issues we had of the actual webinar. I already covered a couple of the questions that I remember from the actual webinar. I went and made sure to cover while I was going here. But one of the other questions that we had was, can I use copy component or copy circuit rather on an actual circuit in a single line? And yes, you can. I just want to point out that there is one thing that you got to be aware of. I'm going to go ahead and copy this circuit. And it's actually fixed in 2018 to where it's not an issue. And you get this dialog box, you need to make sure you do retag all. Not keep fixed component tags or anything like that. Do retag all. That will retag all the components, changing them back to a question mark in our case, and making them unique so they can be connected up to another drawing. In addition, the dot up here always gets a number on it, so I usually have to hide that attribute on that particular one, all because they put, for some reason, they single line component dots get a component tag to it, which is unique to single lines. I'm not sure. Somebody must have wanted that. But basically, you just need to make sure retag all. In earlier versions of before 2018, you got a dialog box that would ask you, give you some kind of warning that, whether you want to retag or not. But the verbiage of it was very confusing. And I had a tendency of picking the wrong one just because I'd read through it fast. And I've had other people tell me the same thing. And what would happen is this one would have been CB115A, just like that one. In that event, they are the exact component. You change one, it changes the other. They're very difficult to break. I found it's easier for me to erase them using the delete component because you still want to use that just like any other one. And recopy it and make sure to retag all. So in earlier versions, there was a little bit of a more difficult to understand, in my opinion, dialog box that caused me to always pick the wrong one. But yes, you can use the copy circuit tag. Outside of that, I do not remember any additional questions that I received during the actual webinar that I need to address that were not covered earlier, and I apologize if I did forget one of those questions. But basically, that is how they work. And this is going to conclude our broadcast here on this with one thing I want to point out before we move on. And that is that we offer training for AutoCAD Electrical here at Hagerman. If you are interested in training, we have new user training coming up this year on December 6th and 8th. also on December 19th and 21st. All three of these are e-training, so they're online. They're 3-day courses. Another one in January coming up. All three in the Eastern time zone. So if you are interested in training, we would love to have you in one of those classes. And if you are in need of any other professional services and training for document management or simulation services, please contact your local Hagerman office. And as you can see here, you can also get a special discount on these 3 classes listed below by contacting the Hagerman office since you attended this particular webinar. I hope this gave you some value in single line diagrams. Thank you.